Welcome to Study Loop.
Okay, so we start with formaldehyde and H3O plus. And this reaction goes to protonated formaldehyde. And neutral water. And the question is, which frontier molecular orbital accepts electrons in the proton transfer reaction? Well, I think it'll be important, or at least helpful, to consider, what bonds are forming and what bonds are breaking. So what we're going to do is draw in the lone pairs on formaldehyde, and then draw out our hydronium. And note that what's happening is that we're creating a bond between oxygen and hydrogen and losing a bond between hydrogen and the hydronium oxygen. Right? So what we should then therefore expect is that this lone pair, the formaldehyde lone pair, should be donating into an antibonding orbital of HOH2, right? Because we're breaking a hydrogen oxygen H2 bond, right? If we're breaking this bond, then the electrons must be getting donated into an antibonding orbital, which is what serves to break this bond, right? Therefore, when we look at the sketches that are available, we have basically an empty p orbital. We have a bonding orbital. Right? How do we know this is a bonding orbital? Because there is significant electron density between oxygen and hydrogen, right? And let me, color the notes here as well. This is just an empty p orbital. It doesn't represent the bond between oxygen and any hydrogen. You'll note that there are no contributing orbitals on any of the hydrogens. Okay, and then the final option, and this is a carbocation, or sorry, this is a cation. And then our final option and what you'll notice is that there's no electron density, or very little electron density, between oxygen and hydrogen, which is how we know this is antibonding. Contrast this with our bonding orbital, where there's significant electron density, and a non-bonding orbital in which there's just no density at all between oxygen and hydrogen, but also no density in this plane, right? So this is our antibonding orbital, and this is 3, which is our answer.